Hello, Ren. I am a student of a school which was previously founded by Elon Musk. I make rockets and I'm interested in rocketry. And today I interview the CTU Space Research Team, Technical University of Prague. Could you please introduce yourself with your name and what you do in your team?
I'm Marek. I'm the team lead.
And I'm Viktor. I'm a lead of propulsion group.
We are over 50 students of different fields and experience. We're the first university team in the Czech Republic developing and building space technologies. And first we decided to go for rockets or start with them. Our mission is to create a sustainable environment where all passionate future or space-oriented people can come, learn, and grow together with others. Brief history about the team is following. In 2019, there was a group of passionate students went to the faculty, to the university, and we presented them our idea. Unfortunately, it wasn't approved. But we didn't give up. We continued working on our own things, let's say, even without the support of the university. But nothing crazy, just smaller projects like hybrid propulsion system, or I was doing something with ionic liquids for ion thrusters. That was also interesting, but nothing like a big team project. First ever Czech competition, nothing too big, not like EuRoC or Spaceport America Cup, but rockets going to 1 kilometer altitude, just solid propulsion system bought or purchased from the manufacturer, not custom. At that point, we were like, okay, let's join, let's work on this. We started, or we applied for the competition. From that moment, we just started moving. As we started moving, we didn't stop. After we competed, we grew, or we hired more people. We asked for the support of our university again. And that time, or this time, it worked. Both our faculty and also the whole university, our rector, were happy about our idea, and they decided to support us, as well as financially, as well as from the, let's say, office space and workshop. They really liked our idea, and they want to have this space-related research space team on the campus. So that's the team story. Sure, it wasn't that short as I wanted, but that's how we started, let's say.
How can someone start a rocketry team in a university?
That's such a good question, and I understand why you're asking. It's not that difficult as it looks. The most important is not to give up. As I already mentioned, we tried to get the support from our university in 2019, and it didn't work because maybe we were too young or not experienced enough, and also the space industry here in the Czech Republic probably wasn't that popular. I don't know the exact reasons. We didn't give up, tried again 2 years later, and it worked. So not giving up is definitely an important advice from our side, let's say. But other than that, I think it's really important to mention that it's good to come to the university with a clear or catchy business page, let's say, exact measurable goal or goals, expected budget, how we want to get the money, if not from the university, let's say companies, sponsors, and what's our long-term vision, because they don't want to hear that it will end after a year or after the first competition. They want something sustainable, or at least that's what they wanted here in the Czech Republic at our university in Prague. And of course, they're also interested how many people we already have, because no people means no work and no team. So they wanted to know that we already have few members who are with us and who want to work on this crazy but awesome thing together.
We were also pretty lucky that we already knew some people from different faculties, because here we study at Faculty of Mechanical Engineering, and since we don't have an aerospace faculty, we are lucky that we knew few people from electrical or electrotechnical faculty, and they helped us a lot with avionics, especially because without them we would have pretty solid hardware. But since we are not taught so much about programming and stuff like that, it really helped to have friends at other faculties.
Correct.
Which are at the team now.
How's the studying in the Czech Republic?
Public universities are for free, so we don't have to pay tuition until you are 26. If you want to study in English, you are allowed to in certain degrees. But for example, if you want to study a master's on our Department of Aeronautics, on Faculty of Mechanical Engineering, you don't have that option. It's not taught in English, sadly. So for aeronautical, you have to go to Faculty of Electrical Engineering. Bachelor's degree, the cost of tuition, if you study in English, is about 4,300 euros per academic year.
But if you want to study for free, and what many students do, is that you can learn Czech first and then study in Czech, because studies in Czech are free. But I think in general, studying in the Czech Republic is, I would say, on a good level. I think, or we have friends, and I've experienced foreign universities a bit, and I think we are keeping up with the world. So, and as well, now we are launching this space team here, which wasn't here before, and we hope, or we believe, we can compete with the European universities, or even in the Spaceport America Cup later on in the future.
Yeah, mostly the study here is mostly about you. You can either just pass the lectures, or you can talk to the teachers and try to come up with some creative solutions, for example, for your thesis or stuff like that. And you can work pretty much on anything you want. They are usually pretty keen on that and
supportive.
and supportive. Yeah. So, but you have to be the initiative one. You have to be the one who comes to them and asks them for the permission to do something a bit extra, a bit different. But they are then very helpful with that.
Do you communicate with university alumni working in space agency like NASA, ESA, or SpaceX, or other companies?
I was in touch with ESA and USPA or USPA, not with university alumni. So that's unfortunately not happening yet.
Because on the, again, specialization of space studies, last year there were 4 students. In the current year, there are only 5 of us, which do study space studies. Study degree just started to exist 5 or 6 years ago, I think. So there aren't many alumni which we can talk to.
What was your preparation before university?
I can say I didn't have any preparation except for the high school, and because we were almost classmates, or we came from the same high school, I would say Viktor didn't have any special preparation either. So unfortunately, nothing like that.
Because still in Czech Republic, the space industry is relatively new and but growing fastly. But no such thing as special space-related high school or something like that does exist till now, sadly.
What are your goals and strengths as a team, and what is your roadmap towards space?
Short-term vision is obviously to go to EuRoC and compete there, and also, and that's already happening, or we are making it happen at the moment. We are creating that supporting environment for students who like or who are passionate about space. So that's the short-term goal or vision. And the long-term one is definitely going to space. So let's say first suborbital, and then maybe later on orbital flights. And I'm sorry actually for using maybe. It's not maybe, I think it will definitely happen one day in the future that guys from our team will reach space and possibly go to the moon or other locations in space. So I think the long-term vision is really promising.
If someone wants to join your team, how can he?
To join the team is quite easy. We have a link on our Instagram account and also on other socials, where people just fill in the form and we get in touch with them, talk about their interests, passions, and we try to find if there is any match. If that person, let's say, passionate enough about specific thing which could be realized or which could be used here in our team. Because, or from my own experience, it's not enough when a passionate student comes, but he wants to do something different and it's not a match, then it just doesn't work. Or if the person is like, I like space, what can I do? That's also not a really not the best situation, because such a person usually I don't want to say gives up, but such a person usually leaves after a while when he or she understands that it's probably not the most interesting thing which they could work on, because they have probably other passions or other hobbies, interests. If you want to know what we expect from the students, or what's, for example, our ideal candidate, there are no special conditions except for that the person is a university student, because EuRoC is mostly for university students. On the other hand, if there is anyone else, let's say even from high school, we can't say no. It would be sad if such a person stopped dreaming just because we were the ones who stopped him or limited him. So for sure, if there is anyone such so much passionate about the space and about working with us, we will definitely welcome him or her.
What can someone learn by joining your team?
Well, you can definitely learn by asking other students and discussing with them, because we have a lot of freshmen here, and let's say the core team is mostly consisting of older students or master's students. Plus, we have some workshops on how to introduce the rocketry to the new members. We have this initial plan of making groups of our members, and each of these groups has to compete on the Czech Rocket Challenge, which was mentioned earlier, which is the rocket competition to 1 kilometer of altitude. So they are starting from the bottom and learning how to build their first rocket, which is developed by or powered by given engine, and then they can join us on the higher level, let's say.
How do you manage your team?
For us as beginners, or let's say newbies, it's actually not that difficult, or it's nothing crazy, because you can use either just Microsoft Excel or even Trello board, or any other Kanban style method for organizing the team. At the moment, we are using Teams Planner or Microsoft Planner because we have the license from the university. Let's say this was the beginning, and at the moment we are working on a bit more advanced management system or project management system with specialized project managers who will be working on that, so that we can keep an eye on all of the progress happening in the team as we grew so much in the recent months.
Also, since we do have a few English-speaking students, we had to set up the communication entirely in English, because we don't want anyone to feel left out. I have to admit that this was pretty hard at the beginning, and still is for some members, since English is not very well taught on this university, to be honest. Our English was a bit rusty since the high school, so we had to improve, and we are still improving. But I think it's a good thing for us, because in today's society, we definitely need to learn how to communicate in English, and we definitely need how to communicate the proper technical terms in English, which is also hard.
And also all the literature connected to rockets is in English.
Yeah,
so I mean, there aren't many sources in Czech. Some people, when they come, they might think something like, "Oh, you're the boss here," like I'm the team lead, but I'm not a boss. I'm not even such a lead. I'm rather the one who gives vision and supports others on the way, kind of like a mentor or a coach. And I think actually both of us or other group leads, we rather mentor others and just solve problems of other members who are, let's say, not that experienced. So we just support the team, and that's the way how we manage our team.
What's the amateur community like in your country?
It's basically hard to tell since there are no exact laws how to define the rocketry in Czech Republic. So mostly it consists of a group of, kind of enclosed communities. Yeah, we are not very much in talks with them. We do know some communities exist, but since our goal is to improve the lectures on the school and to improve how the space subjects are taught and to connect the students from different fields, we don't exactly felt the need to communicate too much with them. We discussed a few basics, such as how to start it and how's the legal point of view on the rocketry, but yeah, nothing crazy.
Would you like to join the Open Launch Initiative?
Well, sounds exciting, and we will be definitely happy or glad to know more about it, and could be really interesting way or test our rockets or rocket before the competitions.
Where do you test your rockets?
At the moment, we don't test the rocket yet, or we didn't get that far. We really want to test our rocket as much as possible. So that includes the real flight of our rocket, hopefully all the way up to 3 kilometers here in the Czech Republic. But we are, let's say, in progress, and we don't know if we succeed or not. So that's something which we'll know later, either in August or September. Hopefully before the competition, because we don't want to come to EuRoC and find out that our rocket doesn't fly as we expected. I would like to ask as well, are you going to EuRoC with us, or not with us, but on your own?
So I think I might be able to go to EuRoC, not as launching rockets because I'm not a university student yet. Sure. I can go there, I think it's like as a media, maybe I think. I hope to see every team goes there.
If you're going there, we are looking forward to meeting you in person.
Yeah, definitely. You are more than welcome within our team.
Yes, thanks.
We are going to make our debut this year at EuRoC, but we are really excited and looking forward to meeting all of the other teams from Europe, and also just getting to know them and just talk and meet other space fans or rocketry fans and passionate people. So we are definitely excited about going there.
Would you like to join a rocket competition?
Yeah, yeah, definitely. We want to participate at least in the Spaceport America Cup in the next year with basically the same rocket. We would be going for EuRoC or with some slight updates, because I was already in talks with one of the flight marshals from Spaceport America, because we met on some Facebook group of amateur rocketry, and he was interested in my bachelor thesis, which was regarding 3D printing fuel grains for hybrid engines. So he was interested and he invited us if the team would work out. Then he said we are more than welcome. So yeah, I would definitely be more than happy to join that. Also, we were looking at Technofest, which is held in Turkey. But yeah, we would still need to decide upon that. So maybe in upcoming years. But yeah, Spaceport America Cup is definitely the one we want to go also to.
But EuRoC is, and I think always will be, our main competition or top priority, because yeah, we are Europe. We are here.
I have a question. I see you have some rockets in the background. What are those?
Sure. Well, the bigger one, that's just a dummy one.
That's just a dummy one with, it used to be our first estimate on how our rocket could look like. But right now, mostly it's for PR purposes. Because, if you take a big rocket outside of the school, more people are interested usually than with just some guys standing. This rocket is actually our first project. It was the rocket we took part in the Czech Rocket Challenge, and we finished second in that last year.
Reaching 901 meter or something like that.
How does this Czech competition work?
Basically, I would say it's becoming pretty much the same as EuRoC. There's like an application process, let's say easier than for EuRoC. And then there are progress reports, then there is the final report, and then there is the launch day. The difference, or the main difference between EuRoC and Czech Rocket Challenge is that Czech Rocket Challenge is also open to high schools, and I'm not sure if also to elementary schools.
Yeah, I think there was no such limitation about that you have to be students. So even older and passionate guys about rocketry took part, which was kind of cool. But yeah, it is second year this year, and it's rapidly developing. So they are kind of trying to find their way, let's say.
Sweet spot.
Yeah, let's say their sweet spot. So you get some points for the maximum altitude, for getting to altitude you guessed or estimated in first, then for technical report, for the presentation, of course. Then I think you get some points for how the rocket looks.
Exactly.
And if you use something, more advanced than open rocket, let's say.
Or just, I think, any innovations
are
highly
like
welcomed for sure.
So practically, if you go higher, you get more points.
I think you're not right, Viktor. I think it's about targeting the altitude which you expected.
No, it's both.
Foremost,
it's both. It actually depends.
Well then, okay.
You need to estimate. Plus, you get extra points if you are able to fly the highest.
Yeah, but the expected altitude, if it's
varies.
the highest, I think
it varies.
Well, we'll see.
We'll see.
We'll see, because
it's a bit unclear. Yeah, it's still their second year.
Yeah, and it's definitely not taken or just copying the rules from EuRoC or Spaceport America Cup. It has its own rules, and just trying to match it to the audience, kind of the high school students mostly, and also the university and younger students possibly.
How do you promote your team and make YouTube videos?
We don't make any YouTube videos at the moment. Yeah, we have one, but it's like a short, just short footage from the Czech Rocket Challenge. But let's say we don't have the human resources for YouTube at the moment, which doesn't mean we don't plan it. We would be definitely happy, but I think we don't have the capacity at the moment. So at the moment, we are focused on Instagram, Facebook, and LinkedIn, where we post and promote our stuff, trying to inspire others and just share with the world that we are doing space stuff here in Prague.
Yeah, we do have a PR department consisting of, I guess, 8 people right now. Yeah, I think 8 people. But as Marek said, they are mostly focusing right now on social media, which are right now the main channel of communication. And by social media, I mean LinkedIn, Instagram, and Facebook.
Exactly. And it's not just the online promotion. At the moment, we also participate physically in person at some events, either on the campus or out of the campus. And we just meet the people in the real world so that they can talk to us and ask what they're interested in, and even join or let's say support us there was such a cool guy who came to us and wanted to cooperate with us as a sponsor. So even that happens during offline events, and that's really nice.
How do you finance your team?
The financing of our team is quite simple. Most of the resources, as I already mentioned, come from the university funds. And then, or next to that, we try to get or arrange partnerships with companies, not necessarily from the space industry, but in general, any companies who are future oriented, and they just provide us with what they do or what they sell or what they know. We don't ask just for the material support, but also for the know-how which they have and which we don't. So we also do that.
How much do you build your own rockets?
Most of the structure and most of the parts on the rocket, but for the critical ones, such as tanks for the oxidizer and pressurizer and valves for that also, we do plan to outsource them and buy them as a whole, or at least let someone professional with experience to build them for us. But we do plan to manufacture carbon fiber panels by ourselves, probably the aluminum airframe also, or at least with some help from our teachers in laboratories. Of course, we want to 3D print some parts, but yeah, we would definitely 3D print some parts, but we still have to decide which ones. The software for the engine, yeah, we use the NASA CEA script, plus our own members wrote some scripts regarding the engine diameters and nozzle shapes and stuff regarding that. So we are using the combination of NASA CEA and our own scripts. And for the CAD designs, we are using Fusion 360. For the simulations, we use ANSYS, MATLAB. For the prototypes, we are mostly going for 3D printed parts, if that's possible. For example, for the engine, we don't want to test the engine in its final form. We want to prepare some metal casing first, because our idea for the engine is to have it reinforced with the carbon fiber in the end. But it just doesn't make any sense to manufacture it with that technique right now for the test engine. So for the prototype engine, we would go for the same inner structure, but different outer structure. We do plan to develop our own hybrid engine, or it is currently under development. Yeah, we would be using some kind of polymer. We currently aim at HDPE, as for high density polyethylene, which has nice density, burns pretty nicely, let's say. And we want to oxidize it with nitrous oxide, which would be pressurized by its own fumes and or vapors, and by.
Do you plan to make a liquid fueled rocket engine?
We definitely want that. At the moment, the liquid propellant or liquid propelled engine is in development, but we don't know yet if we are going to be ready with this until the next EuRoC or in 2 years. We'll see, because we know that that's a hard work and there's lots of challenges on the way.
Do you plan to use thrust vectoring or airbrakes?
We are just dreaming of thrust vectoring, but talking about the airbrakes, we are going to use them for this year's rocket at EuRoC. So that's definitely going to be interesting, as we are going to control it by an active mathematical model, which will calculate or work during the flight in order to reach the target altitude.
What kind of fins do you plan to use?
We do plan to use trapezoidal fins because we estimated them, or they just came up the best out of our research we did on this topic for the speeds we estimate from our engine.
Did you develop your custom PCB to control your rocket?
We do develop our custom printed circuit board. It's an STM32 board, and we are going to just validate and calibrate this PCB, and hopefully it will work.
How do you plan to transfer data from your rocket to a ground station?
We will have wireless connection, wireless telemetry using LoRa, and we are going to buy the antennas for it, as well as the ground station will be mostly bought from the store.
How do you make your launch rail?
We do plan to use the standardized EuRoC launch rail.
Do you plan to make your own recovery system?
Plan to do, or we already presented to the EuRoC officials that we are going to use a custom reusable CO2 system, which will be refillable, and hopefully again it will work. But there won't be any pyrotechnic line or black powder used, just a CO2 tank, which will then release the parachute and all the recovery, including the CubeSat.
Do you play Kerbal Space program?
Yeah, I like it. Actually, one of our teachers, which is teaching the astrodynamics, made it mandatory for us, which are studying that. He even, said which plugins we have to download, and then we got some tasks assigned in that. So in order for us to learn the basics, or to get the perspective of the basics of orbital mechanics, which is pretty well developed here. I know it's not perfect. Like there sure are better programs for orbital mechanics, but if you don't know these plugins, it's pretty great actually. And plus, it's just a fun way to pass around some time.
Exactly, it's fun for people who don't know much about it. Just start playing, and actually, that's how we do it. I mean, all the time I don't want to say we play, because we take it definitely seriously, but because it's kind of our hobby, and we want to work on this in the future. It's really nice if we can just do what we like and what we enjoy. So why not play Kerbal Space along that?
What plugins do you use?
Oh, that's a tricky question. I can definitely look for them, but I can't remember the names right now.
What do you use as your payload?
We do have a 2U CubeSat, or 2-unit CubeSat, and we do plan to have a biological or microbiological experiment on board, but at the same time it would work as technology demonstrator for us to validate that we are able to collect air samples from the air at different heights, because it would have its own flight computer on board. So we want to validate this technology at the same time. We are cooperating on this payload with students of microbiology from Charles University in Prague, mostly PhD students, should be pretty advanced.
Do you want to announce something for this year?
We definitely want to announce something new, but I'm sorry, Eto, I think we should keep something for our own event, let's say, and I believe it will be live streamed, so you'll be definitely welcomed, and we are inviting you to join later on this year.
Thanks. What are your personal future plans?
Well, I want to do my PhD because I like this academic sphere here, and I like the attitude of the professors of my field. The Czech space industry is growing. At the same time, I still think I can do better or more interesting projects when I'm doing my PhD.
That's a pretty hard question, as I'm not originally an aerospace student or in no way connected to that. I am a nuclear engineering student. And, I just like to do something which helps others. And recently I'm enjoying the most when I can help people or provide people with something nice, what they can enjoy, and they can work on it so that they don't feel like they're working and they're just enjoying. So I definitely want to launch my own business or startup somehow around this, that people come, they do what they like. I don't know if it's going to be space oriented or if it's going to be connected to energy field or energetics. No clue yet, but I should figure that out pretty soon.
What is your advice for young rocketeers?
From my side, it's definitely dream big and don't let others limit you or stop you, because that's such a pity. That's such a big pity if people give up just because someone tells them that something is impossible. So that's my advice.
Learn English. It's pretty helpful. First think, and you can move on if you can't speak or at least read English. So it's my first advice to the young Rocketeers. But yeah, never stop dreaming, but also never stop reading. At the same time, read some good books and try to observe the others and try to build upon their ideas.
What are your favorite space movies?
Well, of course, Star Wars. I can't say otherwise. I'm sorry.
Yeah, well, sure. Back then, I don't know if it was one of my first goals in the past. I really wanted to develop way faster engines, but I still don't know how. So Star Wars is definitely a great way how to dream about that or remember such a goal. And maybe one day we'll have a fusion propelled engines or something else which will be even faster. No idea, but I'm really looking forward to that.
Do you have any questions for me?
How are you doing it, and how did you actually get to rocketry and even that school of Elon Musk?
So, rocketry, I am interested in rocketry from as long as I can remember. So I actually don't know how it started. Then for the school which was previously founded by Elon Musk, practically I did the admission for Adastra, which was the school for which Elon Musk made. Then there was the pandemic, right when I had to join. So and also at the same time, Elon went to Texas. So Adastra went online and Elon went away from it, so it became Astronova. So I had this question, which is like sort of in general. Like every team uses some part made of aluminum with some complex geometry. I'm curious why no team that I interviewed yet has made like a mini foundry to build aluminum cast the things.
I was thinking a bit about that because I'm mainly focused on additive manufacturing, and I'm trying to explore the benefits of both commercially available additive manufacturing and the high-end additive manufacturing, which is also my part-time job. But I was thinking about using PLA in the lost cast method, in which you manufacture the final part in PLA, 3D print it, make a cast around it of something, and then burn the PLA out. So then you can cast the liquid aluminium into that and get the final shape. So maybe for next years, we want to incorporate something like that. But right now, we are really trying to succeed. And by succeed for us, right now, it means to compete at EuRoC, to be able to present reliable power source or propulsion unit, and deploy our chute, because we got that last year. Not many teams were successful in that.
So basically, it means as simple as possible this year,
yeah.
And we are going to get crazier or crazy in the following years. And by the way, doesn't it look cool when you have a strange-looking aluminum part? I think that's the reason.
When it comes to difficult shapes, we want to incorporate the additive manufacturing as much as we can. So maybe we would try to get the aluminum 3D printed part.
So what you said before, like how do you burn out the PLA and what do you make the mold out of?
Well, you simply put the mold in the heat, in the oven or stuff like that.
Also, you melt it out.
Yeah, exactly.
And you make the mold out of what, like clay? You have some refractory material, cement?
There's some kind of specific material. I think it's some kind of clay or ceramics. I'm not so sure about that, about the specific. I know it has some specific name, but Yeah, I think it's some kind of ceramics or stuff like that. Actually, using this lost cast method, it is pretty common. The only innovative, let's say, because many people are already doing that, thing is 3D printing the initial model.
You might be interested in Greensand casting.
Greensand casting. Okay, I'll have a look at that.
It's if I'm not I'm not being confused with another name. If I understood correctly, it's you have like 2 boxes. You can do it with 2 boxes. You have a mixture of sand and clay with some water. Then you can have a shape like a PLA mold. You put it in between the boxes. You press. Then you remove the boxes. You remove the pot, and you've got like a 2-part mold. Then you can, like using a finger, you can make a canal where for the aluminum to get in. You close the boxes together, you pour the aluminum, then you let the aluminum cool, you open it, you cut out and sand the additional part, which is which you don't want, where the aluminum was coming in, and then you have an aluminum part.
Yeah. Sure. We have such technology here at the university.
Yeah, we actually tried that a bit.
We tried. Yeah, we tried during our classes.
You made a furnace?
No, we were able to make the mold and try to cast something ourselves.
Without the furnace, there wasn't any need to use the furnace. It was just somehow using the pressure. You just made it, let's say, more. You just made it fixed, kinda, and. Hard, and then you just poured the aluminum in, and that was it.
I mean, like, how did you melt the aluminum?
Yeah, the teachers did that because
exactly.
We have huge laboratories when it comes to that.
Sorry, I thought you meant the furnace for baking
the mold.
The mold, yeah, correct.
We actually have pretty good laboratories when it comes to this because we are able to use the lathe a bit. We are able to do some, blacksmith. Really basic. It's harder than it looks. On the YouTube videos, it's always pretty much satisfying, but we are just trying to get some triangular shape, and it was hard as hell. We had like 60 minutes for that, and none of us was able to make it.
Well, we were, but it wasn't that beautiful.
Nice. Yeah.
You mean like with the hot iron or steel?
Correct. Yeah. Sure.
I know you can practice your blacksmithing skills with a mixture of clay and oil. If you cool it down, it's got a similar hardness and viscosity, I think, to hot iron. So you can practice your blacksmithing on that, and then when you know how to blacksmith, you can do it on the real iron.
Yeah, I was just searching for the lost wax casting, which we discussed earlier. And yeah, it's the mold is made out of plaster or ceramic shell.
Yes, because I know that if you just use clay, the clay has a tendency of breaking when heating.
Yeah.
Also because I think, I don't know if it's like difference in temperature and it being hot, meaning that the outer part expands and the inner part is smaller than the outer part. Something like that, or maybe it's just that there's some water inside, and when you heat it, it just boils and it explodes. Anyways, I've tried to make some crucibles out of clay, and a couple of them exploded.
Well, you survived. So
well, not like it wasn't a powerful explosion. It was like pop, and it flew like.
That's not explosion.
I mean,
when you're talking about explosions, I imagine exploding engines and just dangerous stuff.
And I think once the pot flew like 2 meters, but no.
Wow.
Oh,
it's actually
the pots.
Pretty long for that.
What were you doing your blacksmithing for?
It was just
we
class.
Just had this class which aimed at learning us the basic stuff of designing, of manufacturing.
Yeah,
so when we design something, we at least a bit know how much work is behind that to make it work, and the specifics of these techniques.
It just show us different technologies of how we can manufacture our CAD modules, let's say, or just our ideas, because it's not just blacksmith approach but also different techniques. So we were just shown I would say almost all of them, except for probably additive 3D printing, metals. At least I don't remember any examples of that during our
No, we
classes
weren't
yet.
shown a bit of additive manufacturing, but when it came to classic manufacturing, it was pretty good actually, because
Sure.
once you try it, you have some stuff in your mind when designing something which needs to be made. For example, if you're making something which needs to be casted, you have to separate it somehow from the mold. So you design it with this thought in your mind. You have to make the shapes so you can pull it out of the mold.
If you make it out of a plaster and you put aluminum inside, can't you like bang it with a hammer and break all the plaster?
Yeah. For this method, yeah. But if you want to make something in serial manufacturing, you just can't break each mold. You have to select different type of casting.
I guess Greensand casting with it being sand.
Yeah, exactly. This is one of the cheaper methods, but that's exactly what you need to have in mind. Like you have to design it in such shapes that you can put it out of the sand form or sand mold without breaking it.
Oh yes, because if you have like a bottle, then if you put it inside, you need to fill it up with sand. But then when you remove the bottle, the sand can't stay inside.
Exactly.
I guess you can't make a bottle with the plaster either.
Yeah,
I
for the
mean,
bottle, it's a bit tricky.
I mean, you could do it, and then
you
you drill you surround it in plaster. Then you drill a hole, you melt it all out of the hole. Then you put the aluminum inside of this tiny hole, and then you destroy everything. I don't know how, and you have an aluminum bottle.
Yeah, exactly. This is the way how it could and should be done, I think.
Or you can make two halves and then just.
Yeah, but with two halves, you wouldn't have the inside of the bottle.
Yes.
Or you could have like the outer part in two parts, and then you can put a bit of aluminum, and then you can roll it really fast, making this the centrifugal or centrifugal force. I don't remember how it's called.
Yeah, centrifugal force is the correct term.
And it just spreads on these sides, and then you blow in cold air, you freeze it, and then you separate the two parts, and you've got an aluminum bottle.
Yeah, that's also possible.
Could work. But just feel free to try. That's exactly what we just support. Just dream and try, experiment, be curious. No limits. But yeah, I mean, really good luck with that.
Under advisor, please.
Thanks for joining me. It's been a pleasure interviewing you and talking to you.
Thank you for having us, and thank you for giving us the chance to share and also to talk to you, because it was really a pleasure to meet you. And as we already said, we will be really happy to meet you in person. If it happens in EuRoC or anywhere else, we're really happy to meet you in person.
Yeah, definitely. Thank you for that opportunity to talk to you. Thank you. Bye.
Thank you. Bye.
Bye.